gonna start now, so let's look at my screen. So we are the Open Resin Alliance. My name is Paul. I'm one of the founders of the Open Resin Alliance, and what we focus on is open source resin 3D printing. So you might ask, resin 3D printing, okay, that's something I might have heard of. And open source 3D printing, yeah, sure, that's something that's been around for years, decades even. But the combination of the two, open source and resin, that is not really something that's common for two simple reasons. Reason number one, resin 3D printing is basically just, very simple machines that, are built with few parts and that you can easily buy from China. So obviously most of the machines that people buy are coming from China for like 200, maybe 300, but they're very cheap. And in China, there's a monopoly called Cheetah Systems, who have actually started to develop the software and the hardware for open source, not open source for resin 3D printing, but it's of course all closed source. So when we started messing around with resin 3D printers with a few friends around like 2018, 2019, we had one issue. We had the cheap 3D printers and they worked, but the software was really bad. And we tried to find a good software for it that, had the features we wanted, but just did not exist. And over the years, it got better. There was a new slicer called Lychee Slicer. And that had all the features that people wanted to have. So that's all good, right? Well, around 2020, 2021, Cheetah Systems, the company that actually made those 3D printers and the software, started to actually encrypt their printers so that third-party software would no longer work. You're like sitting here like, oh, this is my 3D printer, but I cannot even choose which software I use. I have to use their software. And their software that comes with this 3D printer that I paid for has premium features that cost extra 170 euros per year. So I sat down with someone from Canada and someone from the US. I'm from Germany. And we started to develop open source resin solutions. So first off, we started with the Prometheus MSLA 3D printer, which was an open hardware resin 3D printer. For that, we used aluminum extrusions, off-the-shelf parts wherever possible, all the standard stuff. And then we developed our own control board. If you can maybe go into the Discord and change to my camera, I think you'd have. Yeah, this is our control board. It's pretty simple. It just uses Raspberry Pi for the simple controls, because the problem with resin 3D printing is you have high resolution screens. You cannot really drive those with simple microcontrollers. There's some controller boards for other Chinese 3D printers that use FPGAs, but they all use either embedded DisplayPort or MIPI DSI, both of which are not really accessible protocols. So we end up using is just this Raspberry Pi, and then we buy the screens with the HDMI adapter included. So that negates one of the hardest challenges, but it's not ideal. Of course, in the future, we're hoping to build our own FPGA solutions for driving the screens, but that is so far in the future as we're a small team. Let's see. Okay, good. So, after this hardware solution, we started the Open Resin Alliance last year, where we're like, okay, we developed all this technology for open source resin 3D printing, but it's just for our own project. Why don't we, try to give this away to everyone to use it, even manufacturers? So that is when we started to Open Resin Alliance. The Open Resin Alliance is basically just, you know, currently our developers from the Prometheus project, but we of course also want to work with other manufacturers. For example, 3D Concepts, which is a relatively new company making resin 3D printers that are currently using not the cheetah system solution, but something from NanoDLP. NanoDLP is also a pretty okay solution. It is not open source though. And well, It has its problems. Let's just keep it at that. So we started to develop our custom solution from scratch. And if you look at my screen right now, can maybe try to make it a bit bigger. This consists of both a backend and a front end, of course. So on the back end, we basically use already existing solutions for open source 3D printing for the regular type, the plastic type, not the resin type. But then we built our own engine that runs on top of that for driving the screen, driving the different electronics, etc. That was just our way to basically avoid having to fork that existing firmware and, maintain it and everything. So we just built on top of it to make things easier for us. And then we also developed our completely own user interface, both available as, a front touch UI and a web interface. Um, and one of the most important factors for this custom user interface was to make it a lot user friendlier than what already exists. So our approach is, yes, let's just use Flutter. Because if you use any Android phone, you probably also know how to use Flutter completely easily, since it's basically the same design language and everything. So the first thing that approaches you when you start our printer is selecting your language. Something very important. Not a lot of Resin 3 printers do this. And some of the machines even ship in Chinese. And then you have to, start the printer, get out your phone, open the translation app to see where you can even change the language. It's a huge hassle. So that is one of the priorities. Make it easy to set up. And I don't like the word because some people might get offended by it, but make it idiot proof. So, select the language, select the country for the time zone, select your exact time zone. Then you can name your printer, since if you have, a print farm, you might have multiple printers, so you might have to give them different names. Obviously, you also have, different IPs, but having user-readable names is always good. We have a dark mode and a light mode, of course. Everything about that is just, it's already provided by the UI, so why not use it? Wi-Fi, etc. So our goal is that we take all of these open, closed source Resin 3D printers and eventually turn them open source. One of the projects that actually Goran worked on too is reverse engineering Resin 3D printers. Something I also did independently, which is, kind of funny considering we both did it in closely the same time span. And our current goal is that not only we want to build new Resin 3D printers that are open source, we want to take the existing machines and hack them to backport our software so that even the old machines with the older hardware that are not really usable since, the software is outdated, you have to pay for a software or it's broken, you know, you can take those machines and either hack the existing control board to install our software or just install one of our new control boards to take those machines and give them more life. Um, and obviously that sounds like, a huge workload. We're a team of three, well, four right now. So it's moving pretty slowly currently, but we're hoping that in the long run, we're going to be able to have like an entire fleet of 3D printers that are all supported by the Open Resin Alliance software and hardware. And that way we can, prevent a lot of hardware going to waste for no reason. Since most of the printers are good, and people, and especially with Raspberry printers, they just buy new printers because those new printers are better, not because their old printers aren't working anymore. And yeah, that's more or less it. That's all I have to say about that.